Hello, everyone. Welcome to our technical walkthrough of Google Maps grounding with MCP. I'm Teresa Ching, Developer Experience Engineer.
I'm Dantong, software engineer from Maps Grounding MCP.
If you've built an AI agent, you've probably realized your agent is incredibly smart, but it's essentially frozen in time. It has no idea what the weather is outside now, whether a local business is open, or best route to your destination. Today, we're fixing that problem. We're deep diving into Maps grounding with MCP. Maps grounding MCP makes it easy to ground your AI agent with trusted geospatial data from Google Maps. We're going to show you how to integrate the Maps MCP with your agentic solution. We have a comprehensive dev doc for our developers. Head over to this link. You will find API spec, demos, and a sample code. Currently, Maps MCP provides three tools for grounding: search places, look up weather, and compute routes. More features are being built and will be available to developers soon. To use grounding MCP service, you can choose to use either API key or OAuth authentication. Good news is Google Maps platform launched a no-cost demo API key that lets you easily start prototyping, and it supports grounding MCP now. Go to the demo key page and click the button to get the key today. Dantong, would you like to walk us through the technical architecture and some best practices?
Sure, happy to. Thank you, Teresa, for walking us through the functionality and onboarding. Grounding MCP is a Google-hosted MCP server, which means you can plug it into your agentic workflow without having to host it locally on your machine. Let's walk through the life of a user query for Find a Cafe near Mountain View. After installing the MCP server to your agent or LLM-enabled app decides to make a call to the Search Places tool with the query Cafe near Mountain View. Google Maps grounding MCP server receives the call and forwards it to its backend to understand the query better and fetch relevant information. It summarizes the findings and returns it to the MCP client in the agent. Your agent then uses this response to answer the user's original question. We'd also like to walk you through a few best practices that can help you get more relevant information efficiently and without hallucination. First, be explicit and specific about your location. Use more precise location for better results. For example, Central Park, New York is a better location than New York. Paris, France is a better location than Paris, as there is also a Paris in Texas. Second, encourage your agent to break down the generic queries. For queries like date night ideas in San Francisco, prompt your agent to break it down to romantic restaurant in San Francisco, movie theaters in San Francisco, romantic bars in San Francisco. This allows you to personalize the query rewrite based on the distinct user needs as well. Third, discover first, exploration second. For queries like book me a Japanese restaurant near Central Park, New York with accessible entrance and open on Sunday. Do the discovery of Japanese restaurant near Central Park with accessible entrance that opens on Sunday first. Let the user pick their preference and then send phone number for a specific restaurant name as a follow-up call to get the booking information. Last but not least, don't hallucinate place IDs. Place IDs are important identifiers that link Google Maps platform services together. Place ID should be fetched from tools like search places. While agents might have the ability to hallucinate IDs, usually it's not valid or might point to other locations.
Now let's take a look at how it works with Gemini CLI. You can find the integration with Gemini CLI guidance on the dev doc. Here I've added the Maps MCP server. I wanted to recommend some good places for coffee and music in Melbourne to me. The model called the Search Places tool and found a vinyl coffee shops. It tells me the vibe of each shop, operating hours, menu highlights. It also reminds me that a few popular places are closed on Monday. All of this information is grounded with Google Maps data. You can also easily integrate a grounding MCP with any agent building framework. Today, I'm going to show you how to integrate it with Google Agent Development Kit, ADK. ADK is an open source agent development framework. It lets you build, debug, and deploy reliable AI agents seamlessly. Here, I'm creating a trip planner using ADK Python. In this agent Python file, I load Maps API key. I give the agent some basic system instructions, including context such as the current date and some guardrails. I also give the agent skills of using the MCP tools and the response styles. Here, I turn on the model thought configuration for debugging. In the skill file, I added tools and guidance for the agent. I also instruct the agent to create a multi-stop universal URL linking to the Google Maps. Here, I launch the agent in ADK built-in chat UI. I give it a prompt as I'm going to Sydney on Saturday, and I want the agent to recommend a trip for me. Now, the agent wants to confirm more details with me. Now you can see the agent gives me all the places based on my context, and it gives me a universal URL for me to view all the places on Google Maps. You can build your own custom UI and render the place details using Places UI Kit component to give your users a rich UI experience. Dantong, could you share some other features of the Maps MCP with us today?
Of course. In addition to the three tools that we launched in Google Cloud Next, we are also recently launching two place resolution tools in experimental phase that will help you to convert a list of Google Maps links or a list of place names to its corresponding place IDs. You can then use those place IDs to dynamically render the UIKit widgets to make the experience richer. This feature is useful when the places are not directly from the grounding services. For example, places that are in your own database.
That's fantastic. Thank you all for watching today. We can't wait to see what you are building. Happy mapping!